Hi, I will present the work entitled 3D tomographic study of the collapse of Eucalyptus nitens wood derived from the drying process. The main objective of this work is to analyze the causes that generate a collapse of the wood during a drying process. For that, we obtain the Eucalyptus nitens species from a commercial plantation in Mexico. This was drying with thermal treatment that follows the conventional temperature sometimes to dry this kind of wood. The samples analyzed were obtained from different parts of the collapsed wood. For this analysis, we produced different size of samples in order to obtain different voxel resolution to analyze at the macro and micro structure the deformation found after the collapse. The samples after the preparation, we obtain different diameter samples, 1 or 10 millimeters diameter, in order to obtain 1 or 10 micron resolution. The sample was mounted in a X-ray computer tomographer, and we obtain images by reducing the noise and by thresholding to distinguish solid and pore phases. Different morphological operations were used, like opening and closing, to improve the binary images. The image analysis was to calculate the pore volume fraction, the pore size distribution of vessels and lumens, and numerical simulation of permeability were run in order to determine different characteristics. So we are showing the sample of 10 millimeters diameter, in where we found a crack that was created during drying. We can notice that this part shows a lack of woody tissue. This is because this part was stirred from this part. So we notice that this stirring is due to higher pressure developed during the drying process, because we found more complicated channels that connect with the vessels in order to evacuate the water, the humidity from the wood. We notice also that the vessels are more deformed when they are close to the crack. This is because larger compression stresses are developed at the border. So in order to analyze the microstructure in a better way, we took a small sample from close to the crack, and we acquire an image at 1 micron voxel resolution. We notice that the vessels that are very close to the larger deformation of tearing are highly deformed. So we can also notice that this deformation is achieved by the pressure of the woody tissue that is in this way. We notice that the rays are also deformed, and they also deform the vessels in that are placed far from the collapse crack. We also notice that some vessels are still in the original shape. This also generates a deformation in the longitudinal direction, which is observed from here and from here, but in this vessel we didn't find it. This indicates that the fluid can not follow the same trajectory. In order to evaluate that, we simulate the permeability in the samples that are in the healthy good and collapsed good, and we notice that permeability is more effective in the collapsed good because the lumens are closed because of the pressure generated during the drying. So this is confirm the reduction in the porosity in the vessels, lumens, and in the global porosity. From that, we can conclude that X-ray microtomography is a good technique to analyze the different consequences obtained during drying process. Also, we can notice that the mechanism of failure is because the fibers cannot support the pressure generated during the evacuation of water contained in the good. So thank you very much.